All right, hi everyone. Today we're going to do a reaction with a primary amine and a carbonyl, and our endpoint of the reaction is to form an imine. And an imine is characterized by a C-N double bond. So originally, we know that we have an H plus cat as on this arrow, and that's signifying that this reaction is happening in an acidic solution. So that means that water is present in this solution. We know that we can't put just HCl or just sulfuric acid into a solution because then it would be too strong to really make any science happen, kind of. So this carbonyl carbon is going to be much more reactive after this oxygen grabs onto a hydrogen in our solution. It can really come from anywhere. And we're going to have, give me one sec. So now our carbonyl carbon has hydrogen on top of it, giving it a positive charge. And this carbon is a much better electrophile than the original carbon because the dipole moment between the carbon and the oxygen is even greater after it grabs a hydrogen. So now this carbon really wants science to happen. And the next part that's going to happen is our nucleophile, the primary amine. One of the lone pairs in the nitrogen is going to come in, attack the carbonyl carbon, causing this double bond to break and give a lone pair of electrons back to the oxygen. So we're going to form, now we have an sp3 carbon. This carbon is now sp3. Originally it was sp2 over here. It's sp2 because it has 3 bonds. One of those bonds is a double bond, but now this carbon is going to be sp3 because it has 4 bonds, and carbons are much happier when they have 4 bonds rather than 3 bonds, excuse me. So after our nucleophile adds, our nitrogen is going to be positively charged because nitrogen has 5 valence electrons, and right now it has 4 bonds. So 5 minus 4 is 1, which is where the positive charge comes from. It's really important to put your charges in there. So we want to make this nitrogen happy, and to do that we're going to have something in our solution, probably water, is going to come and take a hydrogen off of that nitrogen. Hydrogen off the nitrogen. So we have the OH stays the same. We have a nitrogen with only 1 hydrogen now and a CH3. This is our hemiaminol. And we'll get to more of that later. So now, since we know that we're trying to form a CN double bond, we have to get rid of this OH group. But we have to give a reason for it to leave. We can't just break a CO bond because this oxygen is pretty happy right now because it has 6 valence electrons, it has 2 bonds, and it has 4 lone electrons. So its formal charge is 0. It's pretty happy where it is. So we want to give it a reason to leave by having the oxygen grab onto a hydrogen in our solution. It can come from water. So we have an OH2 plus. This oxygen is now positively charged, making it unhappy. The nitrogen stays the same. So now this nitrogen's extra lone pair is going to fold down, form a double bond, and now the carbon-oxygen bond will break, which means that water is going to enter our solution as it was already there. So now we're forming our CN double bond here. The hydrogen's still there, the CH3 is still there, and if you want to, you can put plus H2O, but we already know that water's in our solution, but if that makes you happy, go ahead and do it. And our nitrogen has a positive charge because it has a double bond and 2 bonds, so 5 minus 4 is 1. And I like to think of this molecule as our hot electrophile, and we'll also get to more of that later. The hot electrophile is really important in the reverse reaction. It's also important in the forward reaction, but I feel like knowing exactly what this molecule is and why it's important is good for going in the reverse direction. So after we form our hot electrophile, now we have to make this nitrogen happy. And similar to how we wanted to make our oxygen leave by making it unhappy, we want to make our nitrogen happy by taking away a hydrogen. So the water that we just formed could grab onto this hydrogen, and then we're going to make our final product. So we have our CN double bond. The nitrogen is bonded to the CH3, but no longer a hydrogen. And this is our final product. It's an imine. And I like to think of this reaction happening in pretty much 4 steps, like 4 main stopping points, because we're starting with our carbonyl, and then we're forming our hemiaminol, we're forming our hot electrophile, and then we get to our amine. And I feel like it's easier to split up this reaction into a bunch of different components because if you know what you're trying to make, then I feel like it's easier to go forward with the reaction if you get a little bit stuck. So for example, if we're at the hemiaminol state, then we know that we're trying to form a CN double bond, which means that we want this OH group to leave. And if we're at the hot electrophile state, then we know that we're trying to make this nitrogen happy, so we want to get rid of this hydrogen to form our final product, and our final product's happy because this nitrogen has like three bonds, and it has a lone pair right here. So 5 minus 3 minus 2 is 0. And that's the forward reaction. So in the next video, we're going to do a backwards reaction.